look on the next page of this and then flip the page once and then twice, what do you see all over the place? What do you see? Trig. Yep, so if that makes you puke in your mouth a little bit, this won't be your most fun section. You need to know your unit circle, and you need to know your minor trig identities, not the super fancy pumped up ones, but basic ones. So let's see if you've got them down. What does tangent theta equal? We're going to want to change that to sine over cosine almost all the time. How about what's sine squared x plus cosine squared x? 1. We're going to use that one sometimes. What's cosecant theta? 1 over sine theta, just those basics. We won't do what's cosine 2 theta, and you have to have a double angle one memorized. So it'll be the basic ones, but you need them in here. So with the trig, we're going to approach it the exact same way we approached the last ones. Our very first attack, our very first attack is just to plug it in and hope we don't get 0 over 0. So when I plug that in on the top, right, the 3's are going to cancel when I put 2 pi over 3 in here. So I'm going to end up with sine of 2 pi on the top. Agreed? And this will be a limit, technically, as theta approaches 2 pi over 3. On the bottom, I will have a 3 times 2 pi over 3, or just a 2 pi. True or false? I could have dropped the limit. What do you think? True or false? I could have dropped the limit. It is true, because I got rid of the variable and I'm actually going to get an answer. So with or without it is wrong. Remember, the limit of a constant is just that constant. So this is a true statement, but this is also fine because the theta's gone. I hope I don't get 0 over 0. 100% sure what's sine of 2 pi? 0. What's my answer in this case? 0. That's a good number. All right, this one we're not going to do because it's just easy. So the question becomes, what do you do with the trig if you get something that's not continuous and defined at that value? Which means you're either going to have a hole in your trig graph or an asymptote on your trig graph. That's what the issue would be graphically. Still, what happens though to indicate that when you plug this in, if you get 0 over 0, there's a hole in the graph. If you get a number over 0, there's an asymptote. So that still holds. So let's go plug that in. 100% sure, what's cosine of 0? 100% sure, cosine 0. The 1. This is 1 minus 1, which is 0. And sine squared there is 0. Now I'm stuck. I can't factor, right? I can't cancel the way it's written. So our line of approach is going to be, we love cosine and sines. I call them your besties for trig. So if there's tangents and cotangents, you're going to replace them. Does that sound good? I have this one in terms of my besties, so I'm not going to do anything. But somehow there's got to be, because I'm getting 0 over 0, there's something that's got to cancel out. Wouldn't you agree? It's either got to be the sine on the bottom or the 1 minus cosine on the top. Raise your hand if you see how I can rewrite things using trig identities to find what's going to cancel. You got it? There it is. He's using this guy, and we'll use this guy quite a bit. This equals 1, right? So if I want to take that bottom, the sine squared, here, let's go write it. Let's use some good notation. I'm going to write the bottom as exactly what you said. Devin, right? He said 1 minus cosine squared. That's totally legal. They are equivalent. And I'll stick with you, Devin. So why would that be helpful? Awesome. He's got a difference of squares in there. That's just a trigonometric difference. Love it. So you are finding that piece that's causing the 0. So here's my next question for you, Devin. Can I stick with you here while we've got it going? And I make it. Did I write too fast? You're my last hour, so I've done this so much today. When you cancel these, if I were to graph this in Desmos or on your graphing calculator, would I see, do you think, a hole at theta equals 0, or would I see an asymptote there based on what I just did? A hole in the graph. See, it still holds because my issue canceled off and what's left isn't an issue. If this was a 1 minus cosine and a 1 minus cosine, there's an asymptote there, all right? But I've got a hole in the graph on this trig function, correct? And when I re-plug it in, 100% sure, what's cosine 0? Because it'll throw the whole thing off. 1. Yep, so this would be 1 over 1 plus 1. All right, so what does that mean? So I got a limit of a half. Well, what does that mean? Because algebraically I came up with that limit, but what does it mean? On the graph of the function, what does it mean? There's a hole in the graph. Now I might rephrase that on a test to make sure you really get it. I might say what value should be assigned to, so this function maybe was f of theta equals. I might say what value should be assigned to f of 0 so that the function is continuous. Basically, I'm saying plug the hole up, right? So what value should be assigned to f of 0? 1/2. Exactly. So that's the same. It means I want the actual value to be equal to the limit so that I can sail on through it. So watch how it's the language. So we'll go practice a little bit. So one of our best things to do is, if we don't see our besties, get our besties. Otherwise, we're going to play with it a little bit. So we're going to start with the very first one. What do you think I would suggest you do? I would even do it before plugging it in, because don't you prefer to do sines and cosines versus tangents and stuff? So I would suggest what before you even start? What do you think, Blake? Yes. We're going to change that tangent to sine over cosine. We won't drop our limit because it's not multiple choice, so let's go write it nice. It's kind of a pain to write it nice, especially for me. I've had to do it 3 times today, right? Perfect. Then what? Well, that's insulting your intelligence. Boom, boom, right? There it is. What is 3 sine theta as theta approaches 3 pi halves? You have to be 100% sure, Lizzie. What's the sine of 3 pi over 2? How does she do that so fast? I'm hoping she thinks of where it is and thinks of the y value there. You are totally correct. The answer to this is 3 times -1 or -3. We're going to skip this guy. I think we'll skip this guy. What do you think I'll rewrite on that one? What, sine over cosine. Yep, so I'm going to skip that. Let's move along. All right, so next up, it says sometimes you're going to get functions like this guy. So actually above that, I want you to write this. Limit as theta approaches 0 of the sine of theta over theta. Do you agree with me that that's 0 over 0 on a direct plug page? That's an issue. I already have my bestie. Doesn't get any better. Nothing's going to factor. Nothing's going to cancel. There's absolutely no way to do this one the way I've taught you. There's a proof for what it is in our book, but you won't understand it yet. Well, I'll do it for you sometime, but you're not ready to see a proof for it. So for now, until we get a proof for it, you're going to memorize it. Fair enough? First hour, we made this table, and I didn't like it because I had them by row put in the numbers, and here's what they came out. This one was 0.99 repeated, this one was 0.99, and then this one, the calculator, once it gets past 8 of them, it rounds it. So it rounded it to 1 on their calculators, which I didn't like. So what I did is I went on Desmos, and I graphed it for them, and it was way better. So we like the graphical a little better on this guy. I'll go throw it up here, Desmos. All right. Oh, can you see it? Get it, Christian? All right. So I've got 2 of them that we're going to need to memorize on here, but I want you to watch me play with the numbers in the function. This red one is the one I want you to look at. Do you see how when I come in from the left of 0, I'm up at 1? See it? Everybody nodding? And I come in from the right of 0, I'm up at 1. What do you think the limit is? 1. So just put that in your head. It is 1 because that's not a proof. Do you agree with me? I'm just seeing it, and I'm saying it's up there at 1. Watch me change this number right here to a 2. What do you think that's up there at now? 2. But watch me change the argument in the denominator. Went back to 1. Do you see that? So guess what's going to happen if I take that 2 out and if I replace this with a 5? It's going to go up to 5. That's not a proof, and that's not justification. But if it's multiple choice and you saw it on Desmos and they have sine 5x over x's limit, right? What do you think it is? 5. Now, if I put a 5 down here in the bottom, it's right back to 1. Do you see it? It's not a proof, but it's really good visual. So guess what happens if I do 65 here? Whoa, right? But how high up do you think that got? I actually got up to 65 over 5, but we'll talk about that in a second. But when I do that, look how high it went. 1. Agreed? So if you were on the AP test to see sine of 3x over 3x is limit, right? What are you going to circle? 1. All right? Now look at the blue one. As I come in from 0 from the left and from the right, where does it seem like I'm sitting at? 0. And it should mathematically make sense why this doesn't matter, because anything times 0 is itself. Do you see how I'm just stretched out and approaching 0? So we're not going to prove them, but you're going to memorize 2 of them for now, and we'll eventually go prove them. The 2 I want you to memorize right now are that first one I showed you, that as we come in on that sine theta over theta, we're not going to make the table because I just showed you from the left, from the right, so therefore from both directions we're at 1. You're going to want to memorize that guy. All right, for now. Next up, the other one, we're not going to make the table for this guy either. Because what happened when I changed the argument but did it the exact same in the denominator? I got 1 again. And I could have made that 3 any constant I wanted to, and as long as it matched in the denominator, my limit will be 1 no matter what. So we're going to write that. It's super important that you recognize that this is the exact same expression as this guy. When that's the case, it will be 1. That's not a proof. It's actually a very, very weak argument I just gave you. I gave you a crappy table, right? And I gave a graph off of which we kind of guessed, but the proof has to wait. Do you remember why I said the proof has to wait? It's just a little too hard for you to get right now. But I won't leave you hanging. We'll eventually prove it. What did I tell you? I didn't make the table for this because I don't like them. To be honest, the tables are the worst. But off the Desmos, we could see that this was going to 0 and then 0, so from both directions going to 0. So I think if you write it, you're more likely to remember it. So on the bottom of this page, we're going to write both of them. And I'd put a little star here. What's that star mean? Yeah, I will have you know one of these for at least one question on your test. It's not a super high priority, but you should probably memorize both right now to be safe. So the limit as theta approaches 0 of sine theta over theta gets to be replaced with 1. Anytime you see it. But you have to see exactly that. All right? And the other one, I kind of call this one the annihilator because when you see it hiding in your limit, things go to 0 and it really cleans stuff up. So when you can spot this guy hiding somewhere in the expression, it's really nice because 0 is our favorite number to work with. Those 2, I would commit to memory. All right? We're going to go play. We're going to do about 5 of these. I went way faster this hour, but the other hours were answering my questions so well, they kind of paved the way for you guys to have a shorter lesson. So they were rocking it this morning, especially my second hour. So let's go up here. What do you think I'll do with number 1? Right away. No matter what, Caitlin, we plug it in. So let's go do that. And you can do it in your head because it's legal. What's e to the 0? What's e to the 0? 1. Yep. How about cosine 0? All over 4. What's my answer? 1/4. How many points, if I put one like that on the test, how many points do you think it's worth? 1. The plug-in chugs are so nice, but they are not much bang for your buck because you don't have to do anything, and I don't care if you do it in your head. So, great, but now we have to tackle, well, what happens on some others? Now, maybe you were listening when I showed the Desmos, right? And maybe you know the answer to number 2 just because you saw me play around with it. What's the answer to number 2? 4. And I'm 100% confident. So if it's multiple choice, what should you do? Circle 4 and move on with your life. But is that one multiple choice? So you have to show me why it's 4. So this needs to be played with a little bit. So I'm going to slow down a tiny bit. I want you to go like this. And it seems like I wrote the exact same thing. I did. Because in order for me to use what the theorem actually says, it says that the limit of the sign of some stuff over the same stuff is 1. It doesn't say that this one's 4, right? So in order for me to use that, I really want there to be a 4 down here. That's legal, by the way, Caden. You can go ahead and throw 4 in the denominator, but guess what you have to also do then? I better put a 4 on the top or I've disrupted it, right? So really, what is that red stuff that I just wrote? The red stuff is really what? 1. That's legal. We multiply by 1 disguised as many different things. There's the property from last week that said constants can come out front of the limit. So I'm going to pull the top one out of the way. When I do a rewrite on this, I'll have 4, and then I'll have that limit from the original problem. I'll have the sine of the 4 theta over the theta, and then boom. This 4 over that 4 is 1. What did we say this is? No matter what. Sine of some stuff over the same stuff's limit. That's 1. So this is the work you would need to show me if it's not multiple choice. But if it's multiple choice, what are you going to do? Circle 4, unless you're not confident. We're going to skip number 3, and we're going to go approach number 4 similarly. Are you ready? So I go plug the 0 in, and guess what I get? What do you think is going to happen on your test 80% of the time? What are you going to get? And honestly, the other 15%, you're going to get like a number over 0. So you're going to have to decide whether they go to infinity or negative infinity. This guy is 0 over 0. And I can't rewrite it in terms of my besties because it already is. So let's start. Guess what I'll do with the 2? Pull it out front, right? I don't want it there. That's totally legal. I'm going to pull the 2 out front. I want to create an argument that's identical on the top. I want the 5 theta to also be on the bottom. Guess what I'm going to do with the 3? Pull it out front. That's the same. I didn't do anything. I used the constant multiple rule. That's awesome. I'm going to go down here and say I would love it if you were exactly the same as the argument in the numerator. The minute I throw that 5 down there, Nathan, I have to balance it out. So where am I going to throw the other 5? I am, and while I'm about to put it on the top, because I've done it already a couple times, while I'm just about to write it, where am I actually going to write it? Out front, because it's legal. So my answer is going to be 10/3 times the limit of some stuff, sine of some stuff, over the same stuff. What is that thing I boxed in? 1. All right, do you see how that goes? So you are now going to be in search of, we're going to skip that one too. Next page. Number 6, I'm going to let you stare at it. I want it in terms of my besties, sine and cosine, and it is. Correct? I would love to be able to factor and cancel, but I can't factor a theta out of the top, and there's nothing that's factoring and canceling. It's not working for me, correct? So now I go to trying to find one of those 2 hiding in there. Do you see a sine of stuff over same stuff hiding in there? Or do you see a 1 minus cosine theta over theta hiding in there? Which one do you see, the sine one or the cosine one? I see the cosine one, but I need to mess with the top first. So Bo, you said you saw it. What do you think I'll do first on the top? There he goes. So he said, let's get that 2 out of there. Excellent. Can I stick with you, Bo? Then I got to go to this side of the room. Well, I did call on Harvey. I need a girl on this side. All right. So why will that be helpful? Yes, he's going to do a 2-for-1 move, which is fine. He's going to pull the 2 out front, which I like. Constants that you don't need can go out front all year. They get to go out front of limits, derivatives, and integrals. Whenever you have a constant that's in the way, it gets to come out front. And then, Bo, what'd you say about the top? Awesome. He's seen a difference of squares. Excellent. And then we had the property last week that said the limit of f of x times the limit of g of x is the limit of their product. So you can say that the limit of the product is a product of the limits. So what I really would do if I had to show all my work, again, if it's multiple choice, I'd bail right here. Who do you see hiding in this? I'll block it off, dotted, but don't you. Don't do this in your notes. What is this guy? Be careful. 0. What's the answer to this problem? 0. So if it's multiple choice right now, Nathan, I would bail. But if you had to show your work, there might be a point that says student uses limit properties. And the property says that you can break up a product into its pieces. So technically, you should do this. Unless it's multiple choice, Christian, then just circle 0 the minute you see it. Maybe you saw it from the get-go. Circle 0 because it's a timed test, right? So this is 2 times, what's this guy right here that Bo found for us? Go ahead, Bo, you found it. 0. And then what's this last one? Even though I don't care, because that's why I kind of call it the annihilator. The minute I hit that 0 on the product, I'm done. But just to practice our unit circle, what is this guy over here? 1 plus cosine theta would be what? 2. Yep. So my answer is 0. All right. I've got 2 more. Number 7 gets a little trickier, but I want to show you something that you're not used to seeing, like with trig. Are you ready? 1/7 plus 2/7 plus 3/7. Super hard question. What is it? 6/7. Do you notice how you did this in your head, correct? And then put it all over 7? We usually in this class go this way. We use the property of adding fractions to break it apart. And furthermore, I could break it however I want because addition's commutative. I could say this is 1 plus 2 over 7 plus 3 over 7. Or I could say it's 2 plus 3 over 7 plus 1. I'm allowed to break it apart. We call it if it makes a heart, you can break it apart. So if there's a single term on the bottom, no matter what it is, theta, cosine theta, whatever, you can break it apart. So having said that, let's see who is listening. Think of a good break for this one so I can, again, it's in terms of my besties. If there's a tangent in there, I'm going to replace it. But this is good. And I kind of see those 2 you're supposed to have memorized if I break it properly, because it makes a heart, and I can break apart sums and differences of fractions. But how? What would be a good way to break it? Raise your hand if you see where I'm going to split it. Got it, Kellen? Where is it? Yes. Perfect. And maybe now, I'm just going to stop, Kellen, just for a second and just ask you. First of all, you won't earn notational points on what I just did, right? Let's pretend this is multiple choice, though, and we're just bailing. Do you know what the answer is? 2. Go circle it. Now let's take away the fact that it's multiple choice. I'm trying to get you used to how you need to approach questions. If this is multiple choice, the minute Kellen saw how to break it up, he probably saw the answer in his head, am I right? But if it's not multiple choice, guys, I have to add this to it, right? And which one needs more work? This guy or this guy? The first part of his breakup, oops, that should be a theta. The first part of the breakup or the second part? The second part needs to be the sign of some stuff over the same stuff. So you better put a 2 down here. I don't need a rewrite, but you better put the 2 down there. Where else better you put a 2? Up on top or out front? I'm going to put it out front. Now I can say it's 0 plus 2 times 1 is 2. So be careful. The red is fine if it's multiple choice. If it's not, you need to tack the blue on. Last one, you guys, we're cruising. I want you to see if you can figure out number 9 without me saying anything. And again, we don't do all of them unless I feel the need to do all of them, which I don't. So go try 9. Any tangents, cotangents, cosecants to replace? If so, do it. I'm actually going to go with the first person to figure it out who's not Christian. Or Devin, because they've done 2 of them for me today. So somebody who figures this one out, or you think you did, not Christian, not Devin, and actually not Kellen either. I'd love a girl. This class has a lot of boys. Girls, let's see if one of you guys can. What can you do? Because right now I'm getting 0 over 0. And I'm going to go not Bo too. Those 4 answered my last 4. I'm going to go with a girl. You got it, Lizzie? All right, Lizzie's up. All right, and let's suppose that she started doing that and then she got stuck. This is what I tell you, Lizzie. Don't cross it off because it won't get read, and don't erase it because I won't be able to read it. So anything that's crossed off, so that would give you a point on my test because that is the first step and it's the correct first step. I love it. Did you go farther? Yeah, break it apart. The product can be split. Like it's like 10 and you can make it 2 times 5, right, Lizzie? Can you tell me what one part of your product was? So she's seen the 1 minus cosine x over one of the x's, right? So you're taking care, I'm going to cross it off, but don't you guys in your notes. She's taking care of those, and she's making this x times x. I like that. And she killed off that one. Agreed? And then, Lizzie, what did you multiply it by? Yes, and I'm going to pull the limit out front while I do it so I don't have to rewrite it. In case there's a point for using limit properties, I have it, and then I don't have to rewrite. Love it. All right, Lizzie, let's see if you can wrap it up. What did you say this is? And if I were to say why, you would have to say because you told us to memorize it, which is the weakest argument ever. So just know that. It's horrible. Memorization is the worst. But for now, we have to. And then, Lizzie, what'd you say for this guy? 1. What's our answer? 0. How many of you figured that out? That's awesome. Excellent. All right, so this worksheet is actually not due for a while. There's going to be 3 of them that are a little longer, so I don't make them due the next day. And so this is due Monday with 2 others that you're going to get this week. Another one you get this week you'll finish in class, and another one there's enough time to have it done by the next day. But the homework gets a little tight this week, so write due Monday. But when should you probably do it? If you have time. That's what I mean. I don't take late work because if I'm going to extend a due date, I do it for everybody. And I do it when it's going to take you more than about 20, 25 minutes at home, which this might. So due when? Monday. But I'd come in with it done if you have time. All right, we are done. Over and out. You know what, though? I'm not going to take this off. Let's go look at number 3, just because I have you here. You ready? Number 3 is a little different because it's a stupid piecewise function. I say stupid because they're difficult to work with. You have to have a 2 for 1 or a 3 for 1. With that piecewise function, remember there's a limit. If when I come in from the left, it's the same as when I come in from the right. So we have to check. How do I check that? I have to plug the 3 into the top. Let's go do, and that would be the limit as x approaches 3 from the left. You'd actually have to write that. Limit x approaches 3 from the left, and you can call it of f of x, or 2x squared minus 3x. It doesn't matter. What do we get when we plug that 3 in? I don't know. It's my first time that we got this far. 18 minus, are we getting a 9? 9? All right, so right equals 9. So that function, when I come in at 3 from the left, is sitting up with an open hole at 9 on the y-axis. Now I need to come in from the right. So I'm going to do the limit x approaches 3 from the right of f of x equals. And I'll go 8 minus cosine pi times 3 over 3. So it's really 8 minus cosine pi. 100% sure what's cosine pi. Yeah, it's 8 minus negative 1. What are we getting when we come in from the right? That's that restaurant. We're both there, right, from both sides, but there's an open hole there. So what's the answer to the question? What's the limit? 9. When would you write D and E, Nate? Well, when they don't equal each other. Yeah, like if the first one was 3 and the second one was 4, right? I can't hop that gap without a bridge. So there you go. I don't know, that might be the only piece was. Actually, it's not that long, but there's a lot of writing. So we're going to stick with it. Extended due date on that one.